Okay, this video is going to cover questions 6 through 10. Number 6 is asking you, do you know the transformations of a graph? Um, this is from section 2.5, which I would encourage you to go back to those notes and look at because it'll have more details than I can provide here. Um, Basically, the numbers that are in the equation, the position of them, the location of them, determines what manner it's changing the graph. So anything over here in the front is considered A. A has two jobs. If A is positive, then it's, I'm going to say opening up because this is a quadratic, or if it was like a cubic, it would be Saturday Night Fever. If A is negative, it means it's reflecting over the x-axis. And so if it's a quadratic, that would be opening down. If it's a cubic, that would be Saturday Night Fever flipping. So you'd flip your arms. I know y'all picture me doing that. Um, A's other job is the actual number itself. So the first job for A is the sign. The second job for A is what's the number itself. If A is greater than 1, it's a vertical stretch. And this goes to that rubber band demonstration that I showed y'all with my little hairband. It takes a lot of energy to stretch it really tall and thin. If A is less than 1, it's a vertical shrink. And this would imply that the ceiling and the floor are caving in and it's running out of room, so it's a very wide graph. The next part is what's inside the parentheses. I want you to go back and think of that large capital H we wrote, and I held my arms up and I'm like, anything that's in parentheses, brackets, bars, radical, anything that's inside what picture like a capital H implies some type of horizontal transformation. And the way to remember that is X runs horizontally. So anything right, in here with X is a horizontal transformation. Now, I drew the asterisk because it's counterintuitive. It's always backwards from what you see. So this is a horizontal shift. And I see +7, which would imply you're going to the right, but it's actually going to the left, which would immediately let you eliminate answer choices B and D. The last part, any number at the very, very, very end is a vertical shift up or down, and it's exactly what it looks like. So I see -3, so that would be down 3. So this is going to come down to that 1/2 in the front. Um, it is a vertical, excuse me, it's shrinking vertically by a factor of 1/2. Now see, this is where I don't agree with the way, oh, they wrote stretch right there. Okay, so this is looking to see, do you just recognize that they wrote shrink here, but then they put by a factor of 2, and that wouldn't make sense because if A is greater than 1, that would be a stretch. So that's why A is the correct answer because it says shrink by a factor of 1/2. Number 7, I've copied and pasted that over here. Number 7 is one of those questions where if you're struggling to be able to do it, I would find it as soon as you start the exam and get it out of the way. Um, I'd study this question, practice it, and then when you start the exam, I'd find it immediately and knock it out. This is from section 9.1, which was systems of equations. You've got to set up a system of equations and then solve them to figure out the answer. Systems of equations means we've got to have two equations here. Well, if we've got two equations, that means we're going to have two variables. So we have a snack shack. They mix cashews worth $6.25 a pound with peanuts that are worth $2.10 a pound, and that it yields a half-pound mixed bag worth $1.90. It says, so how much of each, type of nut is included in the mixed bag? So we have two equations here. First, before we set our equations up, we need to discuss what our letters are going to be. I always go with the first letter of what I'm talking about so that as I'm solving the problem, I don't forget what the letter stands for. So we're discussing cashews and peanuts. And if I read it again, it says the cashews are at $6.25 per pound, and the peanuts are at $2.10 per pound. And then when you put all that together, so this is me taking Cliff Notes, it says to get a half-pound mixed nut bag worth $1.90. So it's only half a pound. I'm actually going to do the decimal. It's only half a pound, so not even a full pound. It's half a pound worth $1.90. And they're telling you exactly what it's worth. If you recall from this section, I think the one we had in our homework was like a 20-pound bag of mixed nuts, which is insane. Um, and then you had to multiply the 20 times the price per pound. Notice here it does not say like $1.90 per pound. It just says, hey, that bag that you get at the end, it's going to weigh this much and it's going to cost this much, which means this is a straightforward approach. Had it said you're getting, I'm going to say in green because this is not what our problem is, but what if it was like you got a 3-pound bag worth $2.10 per pound, then you would have to actually multiply 3 times the $2.10 to get the cost of your bag. Okay, so keep that in mind. That's a what if. All right, so now we've got, C's cashews, P's peanuts. We know the price. So the green is just a what if. Take note of what our problem is here. Take note of what it could be, and then know how to proceed. All right, so we're sticking with the blue. We need two equations. One equation is quantity, how much, like, do you have, how much pound-wise, like, I'm going to put LB right here. And the second equation is quality, if I spell it right. The second equation is quality, which brings into price. So that's the difference between the two. Quantity is like the weight of the bags. Quality is the cost of it. Okay, so quantity is always the easier one because it's, hey, I'm mixing cashews with peanuts, and I'm going to get how much in weight? I'm going to get a half a pound of half a pound bag, right? Quality ties in the cost of each. So the cashews are, and this is why the little Cliff Notes is really helpful up here. This is quality cashews are $6.25 per pound. Peanuts are $2.10 per pound. And we're going to pay $1.90 for the bag. Oop, I left my one off. We're going to pay $1.90 for the bag, right? So now we have our two equations, and now you're going to solve this either by substitution, elimination, graphing. I personally solve it by substitution because I see that this equation right here has these nice plain simple variables. So I took that equation and I solved for C, which gave me 0.5 minus P. And then I took this, let me use my highlighter. I took 0.5 minus P and I'm going to plug it in where I see C in the second equation. So we've got 6.25 parentheses 0.5 minus P and then plus 2. You really, $2.10 can just be written as 2.1. If that throws you off, then write 2.10. $1.90 can be written as 1.9. And now I'm going to solve this. You're going to distribute. So we've got 3.125 minus 6.25p. I'm going to bring this down. look at where you've got combined, you can combine like terms. So both of these have a p variable, so this would be negative 4.15p. I'm also going to, in this same step, and I'm going to subtract this over here, which is what gives me negative 1.225 here. Now I would divide, and that's how I get my weight for the bag of peanuts. To get the weight for your cashews, you would plug this in right here, and then you would come to that you're getting 0.205 pounds of cashews, and you're getting 0.295 pounds of peanuts. So that's number 7. Number 8 is an absolute value equation. You have to think back to absolute value. So the purpose, I'm going to put recall. Go to something simple. So if I take the absolute value of 2, I get 2. If I take the absolute value of negative 2, I also get 2, right? So the idea behind an absolute value equation is, first of all, isolate the absolute value part. So we need this by itself. So I'm going to add 3 over to the right. Actually, and I'm going to move this so I'm not right underneath it. When I add 3 over to the right, I end up with this. Once you have the absolute value expression by itself, you now need to split it into 2 possible scenarios. You have to think to yourself, don't focus on what's actually in here. Blur it out and say to yourself, what number could be right there to make this true? Let me change pins. Okay, so a big old 15 could be in there and it would be true, or a big old negative 15 could be in there. And so that's where your 2 equations come from. We're going to say we could have x plus 6 has to be a negative 15, or we could have that x plus 6 has to be a positive 15. And then when you solve those, oops, correctly, that's where you get your 2 answers, which is why the answers are negative 21 and 9. And that's the case every time. Just remember to isolate the absolute value bars before you go and set it up. You absolutely have to move anything that's on the outside before you can set it up. Number 9 is saying graph the function by showing all the asymptotes. This was one that we were studying from, I think, section 4.5. So you've got to go through here and find your vertical asymptote, your horizontal asymptote, and if you look at your answer choices, there's no oblique asymptote. And then we need to know what our x-intercepts are and our y-intercept. Okay, so the vertical asymptote, remember, comes from the denominator. So the denominator, you set that equal to 0 and you solve it. I don't have a lot of room here. If you look at my notes in the answer key, this factors and comes down to x equals 4 and x equals negative 3. So then I would look at my answer choices to see if I can eliminate any of them. You have to be careful. They are counting by 2s. Let's see, negative 3 and 4. Okay, so this looks like this is actually negative 3, and this one is on 4. This one's negative 3, this one's on 4. Okay, so I can eliminate this one because that right there is on negative 4 and positive 3. So we know it's not C. This looks like it's on negative 3 and 4. Okay, so now let's look at our horizontal asymptote. Remember, this is where you check the degrees. You've got three scenarios. If the degree on top, numerator, is smaller than the degree on bottom, then the horizontal asymptote is at the equation y equals 0. If the degrees are equal, then the horizontal asymptote is at the equation y equals whatever the coefficients are. If the degree on top is greater, then there is no horizontal asymptote. Instead, there's an oblique. So if you look at this, we have degree 2, degree 2. They are equal. There's a 1 in front of both. So my horizontal asymptote is the equation y equals 1. So now I can go through and eliminate another answer choice. This looks like y equals 1. This looks like y equals 2, so it's not B. This is, okay, so this one, I don't even have to go any further. So if you look at this, while it does look like there's an understood asymptote here, notice there's no dotted line. But if you come over here, you see this dotted line that they have? That's letting you know, hey, I graphed this horizontal asymptote. This does not have an asymptote graphed. Also, there's a difference in the intercepts. So if you're unsure of yourself, you could go one step further and find the intercepts. The x-intercept is where you let y equal 0 and solve. So when you do that, it's this nice cross-multiplying proportion where the denominator, when it cross-multiplies over to the 0, it always disappears. And you end up, in this case, with 0 equals x squared. If I solve that, I get an x-intercept of 0, which tells me this says no x-intercept, so I know it's not D, I know it's A. So that's a lot for just one problem, and that's something from our last chapter exam. I would probably include those little tips and tricks on your note card, because that might be a lot for you to remember. Number 10, determine if the graph is symmetric with respect to the x, the y, or the origin. The x means can you flip down and it match. The y means can you flip left and it match. The origin means can you rotate 180 and it match. I mean, it's as simple as that. Now, I can't demonstrate this on the computer, but basically take your paper and imagine if I folded this, like think of this as a spinning axle. If I flipped it down, would it match? No. If I flipped it left, like spin it left, would it match? No. If I take my paper and turn it upside down, does it match? Yes, which is why the answer is A.